So we've got ax squared plus bx plus c equals 0. Again, because we want to keep that second degree power, we don't want our a to be 0, because if a is 0, 0 times x squared will become 0, and you end up losing that term, which means now you just have a straight line, right? You don't have a quadratic equation anymore. So that's why we put that restriction of why a cannot be 0. So here we're talking about just solving quadratic equations, and that's actually what this section is going to focus on. So we're going to look at different methods of solving the quadratic equation. We're actually starting out with the factoring method here. So factoring basically means we're trying to break this guy down into two different simpler polynomials, which will be just degree 1 polynomials, right? So if this is x squared, these guys will break down into x and x. So the idea is if I break this down into two factors, then how do we come up with the value of x? And that's where this zero factor property actually comes into play. So the idea is if I have two factors, and we are saying it's equal to 0, then that means either the first factor or the second factor has to be 0. I mean, think about it. If I tell you 15 times some number gives you 0, well, what do you think that second number has to be? 0, right? And it would be the same thing if I gave you blank times, I don't know, negative, we'll just make it negative 15. Again, if I'm telling you the answer is going to come out to be 0, that means that missing number again has to be 0. So they're actually using this idea that if you are multiplying two numbers and your product comes out to be 0, that means either the first or the second number has to be 0 for your product to come out to be 0. So we actually use this idea of zero factor property to simplify and come up with the answers for our quadratic equations here. So we're actually going to look at factoring for this. Again, you know, of course, going into this class, we're assuming you guys are comfortable with factoring, but then those of you who are in the lab course will definitely be going a lot more detailed into the factoring. But for now, I will show you how we can go about factoring this guy. So let's look at, so you are given 2x squared minus 5x plus 2 equals 0. So there's two different types of factoring we do. One of them is where you don't have that leading coefficient, it just starts with an x squared. So that technique is just a little bit different. But then you have expressions like this where you actually have a leading coefficient, so there's some number in front of that x squared. So that has a little bit of a different technique when we multiply this. So do you guys remember how you would normally factor something like this expression here? What have you learned? What kind of techniques have you used? So what do you mean? How would you go about with the least common multiple?
What can go into each number?
Okay.
Would it be 10? Or not?
Okay. No. That will not work in this case. No. So you can either bring something out if there was something common between all three of our numbers here, but of course between 2, 5, and 2, 1 is the only number that's going to be common. So really bringing a 1 out doesn't help us. So what other techniques can we use? So what I have heard normally from students is either the trial and error method where you keep multiplying numbers till you get the expression that we have here. And that would actually involve, so I'll show it to you that way and I'll show you another way. You can choose which you like. So the trial and error method is where we start out with our 2x squared term. And now we know this is going to factor into two expressions. So your 2x squared, you can just treat that 2 as 2 times 1. And then each of your factors is going to get an x term. So you can have 2 times x and 1 times x or just x. And then you would do the same thing with that last term, the constant term, which is 2 and 1. Now the idea is, in what order do we put that 2 and 1 such that we go back to getting that negative 5x? So this is where you want to check and see, is this going to give me what I'm looking for? Another thing to keep in mind with factoring is, if this guy is negative in the middle term and it's positive in the last term, both your factors are going to be negative. Okay? But am I getting my negative 5x when I go ahead and multiply this? So the way to check that and see if you're going to get negative 5x is multiply these two inner terms. So negative 2 times x gives you negative 2x, and then multiply these two outer terms, which will be 2x times negative 1, which also gives us negative 2x. And when we add negative 2x and negative 2x, what do we get? 0.
Negative 4x.
Negative 4x. So here's the problem. It's not negative 5x, right? So that means the 2 and the 1 in this position does not work. So this is not the right order. So we change that. And instead of writing it this way, we will now write it as 2x minus 1 and x minus 2. So you're basically switching the places of 1 and 2. And we would still need to do this little check to make sure I still end up with negative 5x. So now, when I multiply the two inner terms, that's negative 1 times x. It's negative x, right? And then the two outer terms, negative 2 times 2x is negative 4x. And when I add them, negative 4 minus 1, negative 5x, which means this is the correct order.
Stupid question. Where did the negative 2 and negative 1 come from?
So
Factors.
that's the factors for number 2, right? So
Oh.
2 is only a product of 2 and 1, right?
So just factoring that.
Just the last constant term, yeah. And then the negative is coming since my middle term is negative and the last term is positive. So whenever you have this order on your signs, both your factors have to be negative.
Okay, I was thinking least common denominator with all of them or something.
Yeah, and that would, I'm not entirely sure how you're thinking of the least common denominator, because that normally only is when you are adding and subtracting fractions, right? So I don't know if you mean greatest common factor or you mean least common denominator. So yeah, you're not sure.
All
That's
in my
okay.
head.
That's fine.
But
And
that makes sense.
the more practice we do, hopefully that will help you clear up some of that confusion. Okay. All right. So getting the factors is half the thing, because we still have to solve our equation. So putting it all together, our original problem was 2x squared minus 5x plus 2 equals 0. We know it factors into 2x minus 1, x minus 2. What else can you do with these two factors to make sure you are actually getting the original expression? Do we remember the term FOIL?
First.
Yeah? Outer, inner, and the last. Yeah, so that's where you actually multiply your factors. So when you are talking about first, that's going to be the first from each expression. So when I multiply that, that gives me 2x squared. When I'm talking about FOIL, outer, that's going to be the outer from the entire expression. So this is the outer and this guy, so that will give me negative 4x. Inner, that's going to be the two inside terms, which is negative 1 times x, negative x. Last is last for each expression, which will give me positive 2. So if you combine these terms, 2x squared, add these guys together, you get negative 5x plus 2, you are going to get your original expression. Okay, so factoring is basically taking a number and breaking it down, or in this case, an expression. Again, remember, the idea is you have done this before, you are comfortable with it. We will be talking about it in the lab, but we don't really talk about it in the class itself. Take your expression, factor it. Now, this zero factor property comes into play. So now that we have our A and B equal 0, right, because we got our two factors, you take each one of them, and now you set them equal to 0 to see what answers you come up with. So at this stage, we are ready for that zero factor property. So I take 2x minus 1, set it equal to 0, or I take x minus 2 and set it equal to 0. And you're going to get two answers coming out of these two expressions. So of course, you're trying to get x by itself. So go ahead and do your math and let me see what answers you get for x. As I said, you should be coming up with two answers for this guy. You have the answer?
Yeah.
Good you got. All right, very good. So basically the goal is to isolate the x, right? So start by moving the constant term on that first part, which means we start by moving the 1 to the other side, and then of course to get rid of the 2x, the 2, divide by 2, right? So what are those two numbers for your x coming out to be?
I got x equals half and x equals 2.
Both positive? Same thing for you? Okay, anybody else get a different answer than this? So you said positive 1/2 and positive 2.
Yes.
Anybody else get a different answer than that? Okay, very good. Yeah, that should be it. So like I was saying, start by adding that 1 first. So they will cancel out, giving you 2x equals 1. And then to get the x by itself, since we're multiplying 2x, or 2 with the x, you would divide, giving us x equals 1/2 from here. And this guy, of course, is not too bad because all you have to do is just move that 2 to the other side, and you end up getting x equals 2. So those should be our two answers.
Got a question.
Sure.
These packets that we're filling out on here, these are just for us, right?
Just for practice.
Okay. So
Yeah.
because I'm trying to focus and write at the same time, that's messed me up. If I just write the answer here after we're done, so I can focus here, because that's what I really want to do, is just understand it. We're not going to be great on
Not the packet.
Okay.
But the only thing is you have similar examples in homework,
Right.
quiz, and exam, right? So all of the examples we do here, I make sure that you have equivalent examples in your homework. And then from whatever you have in your homework are the same questions that go into your quizzes and exam. So yeah, I mean, if you're comfortable by just paying attention, looking at the steps and not having to worry about writing it down, you can definitely do that. And then, I post these on D2L. So if you ever get confused and you're like, okay, what were the steps? You can always go and look at the files in D2L. So that way, yeah, if you're not wanting to worry about, writing everything down, you don't have to.
I need to pay attention to
I
what you're
agree,
doing here, 'cause
Yeah, sure.
You just copying stuff down.
Sure. Yeah, the handouts are just so that you didn't have to write everything down on your own, all the explanation and all of that. That's the only purpose. So the way we write the solution set down for this kind of problem, because it's exactly two numbers, right? That is going to satisfy our equation. So to write those two numbers down, we use what we call as the set notations. And normally we write the smaller number down first, and the larger number down second. MyMathLab doesn't care. You can put 2 first and then the 1/2. But just as a common practice, the smaller numbers always go first. And remember, the idea here is if I take this value of 1/2 and put it into my original equation, like we saw in 1.1 section, if I put 1/2 in for my x, I should get a true statement, 0 equals 0. If I take that 2 and replace my x with it, again, I should get 0 equals 0. So basically, we are saying when you are solving this equation is that you're finding the value of x such that your left-hand side will match your right-hand side. And in this case, it will always be 0 on the right-hand side. So you should end up getting, when you do a check, 0 equals 0. Okay? What's the first thing you're noticing here in number 2? Very nice. It does not equal 0. And what else?
There's 2 y's.
They're giving you sort of a factored form, right? But the only, I guess, unfortunate part here is this does not equal 0, because if it equals 0, you were already at the second step of the problem. So we're actually going to need to FOIL the left-hand side, bring the 30 over to the left-hand side, get our expression, and then we have to factor it. So this is actually not ready to be solved just yet. We have to actually clean this problem up before we can solve it. This guy is y minus 3, y plus 4 equals 30. So let's start with the FOIL part. So multiply the first terms, the outer terms, plus u, the inside, and the last. Okay? So that's y times y squared, very good. Y times positive 4, 4y. Negative 3 times y, negative 3y. And the last ones would be negative 3 times positive 4. Yeah, negative 12, so be careful about that. And of course, we still have that 30 on the right-hand side. Now again, you should notice that these two are like terms. They are y and y. So we can combine these guys together. Y squared. What's positive 4 minus 3? Just y, yeah, 1y. So positive y minus 12. And then we can bring this 30 also, right? So you can subtract that 30, because we always want to have 0 on the right-hand side when we are solving these equations. So what's our final answer going to look like, or equation going to look like? Yeah, y squared plus y minus 42 equals 0. Once you have this guy equal to 0, then we're ready to solve it. So this was just to kind of show you how sometimes they will change up the equation on you a little bit. Before you're ready to solve it, you need to clean it up, simplify it. Okay, so we've got our y squared plus y minus 42. We have that trinomial on the left-hand side. We've got 0 on the right-hand side. So now we're ready to factor it. Now, the one thing you should notice in this example compared to number 1 is in front of our y squared, there's no number, right? So it's just understood to be 1. So our factoring for this guy is actually going to be a lot simpler than it was for that one. So your constant term is negative 42. What's the coefficient of our middle term? Plus 1. So you're honestly looking for two numbers that multiply to give you negative 42, but add up to give you plus 1. And there aren't that many options, right? 7 and 6 give you 42. Yeah? Okay. Now, which one? Because we still should get negative 42 when we multiply. So which one of the two numbers should be negative? Which one should be positive? And you said the same thing, right? -6. And why are we making the 6 a negative and not the 7? Exactly, because when we add the two numbers, it should add up to +1, right? So since the addition is giving you a positive answer, which means the larger number has to be positive and the smaller number has to be negative. And you can play around with the combinations like we did with the trial and error and see which sign should be on which number. So when you factor this, again, it's going to factor into two factors. Your y squared will still break down into y and y. I have a positive in my middle term, but a negative in my constant term, right? And we know we've already got the numbers to tell us that, but usually, again, the setup is if this guy is negative, the constant term, it doesn't matter if the middle term is positive or negative. If this guy is negative, you will always have opposite signs in your factors. Okay, and then of course we know the negative goes with 6, the positive goes with 7. And remember what I showed you in the previous example. You can always do a FOIL on your factors and make sure you come back to the original expression you started out with if you wanted to check your math. All right, so once you have your factors, use your zero factor property to come up with our answers. So that's going to be y minus 6 equals 0 or y plus 7 equal 0. So what will those two answers be? 6 and -7. Yeah, very good. So with y plus 6, minus 6, you add the 6, move it to the other side. You get a positive 6 from here. And then y plus 7, we would subtract that 7 to move it to the other side. So our solution set is going to be -7 and +6. And did you for that matter that you put it in that order? Oh, only it's the greatest. Usually we do the smallest to the largest, but like I said, my math lab is not picky, which is a good thing because it can be picky on other parts. It's good it's not picky on this. And in this example, since we had the factored form on the left-hand side and 30 on the right-hand side, when you put your -7 or 6 back into the original equation, you will actually get 30 equals 30 instead of 0 equals 0, just because the original problem was set up different. So the idea is as long as you're getting a true statement, your solution is good to go, right?
If we had to use FOIL, we can only use FOIL with binomials, not trinomials, right?
It's not called FOIL, but it's the same method, right? Because the idea is if you were doing, and let me just show you that. If you were doing y plus 2 with y squared plus y plus 1, right? The idea would still be the same. You would still have to take the first term, multiply with each one of the 3 terms from the other one, then you would take the 2 and still multiply it with all 3. So it's just not called FOIL because it's not just those 4 terms, but the concept is still the same. You're still taking each term from the first one, multiplying with each term from the second one. Yeah. Very good. Any other questions on number 2? So remember, this problem was a little bit different because we had to clean it up before we were ready to solve it. So factoring is one method that you can use for solving these quadratic equations, but not every expression can be factored. So factoring actually is going to be a very limited process. Not every expression can be factored, so we won't be able to use factoring generically with all quadratic equation. So we're actually going to look at some other methods also. So here we're going to talk about square root property, but it's the same thing with square root property. It has its own limitations also when it comes to solving the equation, because you know, square root property really only works on these type of equations where you have x squared equals k. So it doesn't have to be exactly x squared, but the idea is you should have a square term on your left-hand side and a constant term on your right-hand side if the square root property is going to work. And one thing you have to keep in mind when we talk about square root properties, you are going to get one positive and one negative answer when you are working through this, because you know the idea is when we're talking about squares and square roots, think about this. Um, if I talk about the number 4 and I take a square root on 4, what numbers can I multiply to get 4? 2? What else?
1 and 4.
No, 1 and 4 will not work because with square roots, they don't work. But other than 2, what other number can be multiplied into itself but still give us 4? Negative 2, because we can do 2 times 2 and still get a 4. We can do negative 2 times negative 2. And we know the two negatives will become positive, right? And then 2 times 2 will give you 4. So that's why when you talk about roots, square root, especially for any of these numbers, you're actually going to get 2 answers for square root, which is going to be 1 positive, 1 negative. Think about number 9. Same thing, right? I can do 3 times 3 and get 9, but then I can also do negative 3 times negative 3 and still end up with a positive 9. So square root property, you are always going to get 1 positive and 1 negative root when you solve these. All right, so let's look at the different types of solutions we'll get from here. Now, you know this number k that you have on the right-hand side of your expression, x squared equals k. If k is positive, something like number 4, number 27, or whatever, you are actually going to end up getting 2 real solutions, like your positive 2 and negative 2. But if that number k happens to be a negative number, so negative 4, because you cannot really do a square root of negative 4. Try putting it in your calculator, square root of negative 4. It's going to give you an error message, right? Domain error or something like that. So that actually means you no longer have real solutions. What you have is imaginary solutions at this point, because you're going to get imaginary numbers as your solution. And we'll talk about that in a little bit. And of course, if you have your k, if the right-hand side is 0, you're actually only going to get one answer. You'll just get one solution on that side, and most of the time it ends up being 0. But in some situations, it can be something else. So I wouldn't always say it's going to always be 0. Your textbook says that, and I'll show you, it can actually change. But the idea is if you have k, which is a positive number, you should get 2 real solutions. If k is a negative number, you will get 2 imaginary solutions. And if k is 0, you should only get 1 real solution. Okay, so let's see how we can use the square root property here on number 3. So of course, think about this. We're saying the square root property works on equations of this form, right? Which means we want to get that x squared by itself. We want to move that 8 to the other side so we can kind of make it look like this form of x squared equals k. So of course, start by moving that 8 to the other side. And this looks more like our equation there. Okay, So this is where we kick in with our square root property. So the idea of using a square root is if I have a square, the thing that cancels out a square is a square root, right? Just like the opposite of minus is plus, in that same way, the opposite of a square is a square root. So when we use the square root property, we take a square root on both sides of our equation. And because this is a square, you can end up getting two solutions. So that's why we always end up with that one positive, one negative solution. So taking a square and a square root, they cancel each other out. And this is how we actually just get our x by itself. Now, this is where you're going to have to be a little careful when you are simplifying that right-hand side. Because if you just type in square root of 8 on your calculator, most calculators are going to give you a decimal answer. Unless you have one of those math type calculators which simplify radicals for you. So remember, no decimal answer. You need to simplify your radical. And we have looked at square root of 8, I think last class. So 8 itself is not a perfect square. So we need to bring something inside of 8 that will be a perfect square. So if I factor 8, 8 is a product of 4 times 2, right? Or 8 times 1, but again, 8 times 1 doesn't help us. 4 is a perfect square. So I can take square root of 4, which will be 2, but this 2, he cannot be simplified, so he continues to stay inside. But please remember, you cannot leave your answer as square root of 8. You have to simplify it into 2 times square root of 2, and then you will get one positive and one negative answer out of it. Okay? So simplifying radicals is definitely very important. And then again, just write your solution set down, which will be negative 2 square root of 2 and positive 2 square root of 2. So obviously you can see we still come up with those two answers. We had a positive 8 when we were looking at this. Didn't have to worry about imaginary solutions for now at least. Question on number 3? So we're changing it up a bit on number 4 here, and this is kind of what I was talking about. Now you can see we have 0 on the right-hand side. We actually do have a square term on the left-hand side. It just happens to be inside the parentheses, right? 5x plus 2, but that whole thing is squared. So technically, this is still in the format of x squared equals k, where our k happens to be 0. Now, what's going to happen for this example? You're not actually going to get 0 as your solution. You are going to get a different answer when we do this. So let's take a look at how we can simplify number 4. So this is parentheses 5x plus 2, the whole quantity squared, equals 0. So this is still in the same format. So since my entire expression is inside the parentheses with the square on the top, when I use my square root property, it's actually going to be on the entire thing. And then, of course, we're going to do a square root on the other side of our equation also. And remember what I told you, with square roots, you always get one positive and one negative root, always with square roots. On the left-hand side, your square root will cancel out that square, right? So you will actually be able to get that 5x plus 2 because now everything around it is gone, it's been canceled out. What is square root of 0? 0. Yeah, hopefully, right? Because otherwise there's something really wrong. So yeah, and you can verify this just by putting it into your calculator. Square root of 0 will be 0. And does 0 take a positive or a negative sign? No, because 0 is 0, right? Sometimes, and we will actually see this later on, for our benefit, we can actually give 0 a positive or negative sign, but it's very specific to what you are doing. In general, 0 does not take a positive or a negative sign. So math is one of those things, if you want to tweak it, we tweak it for our benefit, but you can't do it all the time. So in this case, 0, of course, does not take a sign. So this is why you actually don't come up with 2 answers, right? Because your 2 answers normally come from one being positive, one being negative. So whenever you have 0 on the right-hand side, you don't get 2 solutions, you only get 1 solution. And all you got to do is get that x by itself. So what will that answer be if we get x by itself?
We're going to subtract 2.
Subtract 2. Yeah, very good. And then divide both sides by 5. So like I was saying, you're only going to get 1 solution. It just doesn't happen to be 0 in this case. So only one number. A question on 4?
Now, when we put it as the solution set, since the solution set typically always requires the 2 numbers, this one is the negative, there'd be no way we'd ever put any positive.
Not for this one. Yeah, because you had that 0 on the right-hand side, so we didn't come up with 2. And again, for your homework, the problems have been designed for what answers to expect, so you're not going to run into any trouble in terms of not having those 2 answers. All right, very good. Any other question popping in mind? Okay, so now number 5, as you will notice, is a little bit different because I still have that x minus 3, the whole quantity squared, but I am actually giving you a negative 20 on that right-hand side, right? So that's that second scenario that I was talking about, where if you have a negative here, you're going to end up getting an imaginary solution. So let's take a look at how we can do that. Again, this is in that same format of x squared equals k. You can see I have a square term on the left-hand side and some constant term on the right-hand side. So again, to get rid of the square, we use a square root. So square root on both sides. And with square roots, we get one positive, one negative. Left-hand side will clean up because the square and square root cancel each other out. You're left behind with just x minus 3, right? And we're going to have a positive, negative, something coming out of here. So let's just take a look at that square root of negative 20 and see how we need to go about simplifying it. If the negative was not there, we could have simplified 20 like we simplified that square root of 8, right? We will try to bring something out of it that was a perfect square. But that negative is actually what's giving us the imaginary solution. What happens if you type square root of negative 20 in your calculator?
It'll be an error.
It's going to be an error, right? You should get, I'm not sure if it's a domain error or it just says error, but you should get something popping up. So in this case, what we need to remember is that we define square root of negative 1 is defined as the imaginary number I. And the only reason we do that is if we take care of that negative sign inside the radical, then we can use normal simplification methods to at least break down these numbers like square root of 20. Something else to keep in mind, if I take -1 inside my square root and I take a square on both sides of that, you actually end up getting -1 as the definition for I square. So I is defined as square root of -1 and I square is defined as -1. But this is the part right now that we are interested in, is what is I defined as. So if I actually take my square root of -20 and separate the negative sign by using -1 multiplied by 20, then that square root of -1 will actually simplify as the imaginary number I, and I will actually be left behind with a positive square root of 20 because I'm separating that negative right from the number. So this guy here, square root of -1, becomes I, and I now have a positive square root of 20 that can be simplified. So think about how can you factor 20 like we did with 8 to bring something out that is a perfect square. 4 and 5, yeah, you can do 20 as 2 times 10, but neither one of those are perfect squares. So the combination that works in our benefit is 4 times 5. Because again, square root of 4 is 2. Square root of 5, 5 cannot be simplified. So he actually stays inside the radical, and that I, we put it in the middle. So your, I guess, naming would be constant term in the front, I in the middle, radical at the end. So square root of -20 cleans up into 2I square root of 5. And you of course have two from the positive and negative, two solutions. So look through this and tell me if you have questions on any step, any part that you didn't understand or you need an explanation again.
So right away, we can plug in -1 times whatever that
Number
we
is.
know it's going to be an imaginary number.
Right.
You just know we can use that rule for just -1.
Yeah. So you can honestly, you don't even have to worry about breaking it down like this. You can go directly from square root of -20, and you know that negative sign is basically coming out as the I. And then you have positive square root of 20, and then you can simplify that. So this is just to show you how the breakdown happens. But yeah, anytime you have that negative inside the radical with your number, that negative is going to come outside as the I, the imaginary number, and then you have a positive value that you can simplify. Okay, so the solution set for this guy is going to be -2I square root of 5 and positive 2I square root of 5. So it's only when you have 0 on the right hand side you get one single answer. Otherwise, you will end up getting 2 real solutions, or in this case, 2 imaginary solutions.
Do we not have the 3 to the other side?
Sorry?
Do we not have the 3 to the other side?
Oh, I didn't finish the problem, did I? Yes, we do have the 3 to the other side. Completely forgot about that. Sorry. Okay, we do have to get that x by itself. Okay. Okay, we simplified that. We need to add 3, which means your answer is actually going to change a little bit. You have x equals, that 3 is actually the real number part, right? Because it doesn't have any I with it. So that's your positive 3. I've got my plus or minus And then, of course, our 2i square root of 5. Yeah, thank you. I didn't even look at that. So in this case, you are actually writing it as what we call as complex numbers. Complex numbers basically mean they are a combination of real and imaginary numbers put together. So normally, again, we put the real number part in the front and the imaginary part at the end. So your solution set then will actually, like I said, will change. You still have two answers coming from that plus or minus. You're going to have 3 minus 2i square root of 5 and 3 plus 2i square root of 5. So basically, with the plus sign, you get one answer. With the minus sign, you get the other. Okay. Square root property. Any questions other than the little blunder? Okay, so you will actually see variations of these examples on your homework. Like I always say, go through those. Let me know what you think about it. If you're getting stuck on any of them, please definitely come back and see me about that. So we're not starting this today, but I wanted to show you completing the square is making a reappearance here, right? We talked about completing the square when we had looked at circles last time, and we were trying to find the center and the radius of our circle. So we're actually using that same technique of completing the square to help us solve quadratic equations also. So completing the square is actually another method which keeps showing up in different places as we go through this course.